Uh, Sorry about the TV set. It got destroyed on the way over here. Uh, I'm usually real careful with something like that, but yeah, things happen. Anyway, this is of course about the double bazooka antenna. The double bazooka antenna, uh, well, that's not a double bazooka, but that is. Okay, I've got two examples here. Uh, One of them is in an inverted V configuration, and the other one is horizontal. And you can look at those if you wish. And the history of the double bazooka, the exact history of the double bazooka antenna is a bit hazy because of the popular name bazooka. The following information was available on the internet, though. Uh, NBC engineers, led by William H. Smith, developed the double bazooka antenna in the early 1930s as part of efforts to improve the quality and reach of radio broadcasts. The first installation of double bazooka antenna was at NBC's radio station in New York City, WEAF, now WFAN, in 1932. The first patent for an antenna like the double bazooka was filed in 1937 on patent number 2184729. It was a vertical antenna. In 2006, patent number 715497 was issued for an antenna that closely resembles the double bazooka that we now know. Double bazooka is a modified quarter-wave dipole antenna. The double bazooka uses coax shielding as part of the active element. The inductive impedance of the wire combined with the capacitive inductance of the dielectric partially cancel each other out, thus improving bandwidth and SWR. The larger diameter of the coax also helps to improve the gain of the antenna. When you're making a double bazooka, please take care and use cable that is slightly lossy, like RG8X or something. If you've got coax that has foil shield, you cannot use that for a double bazooka. I mean, you could use it, but it won't be any good. The double bazooka can be configured as either a horizontal antenna or an inverted V. Both of those antennas, if anybody wants one, you can take them when we're done. The horizontal configuration offers a high radiational efficiency, but more directionality and a straightforward installation, but uses more space and is prone to sagging, especially if you're doing like a 40 meter or something like that, The inverted V consideration offers reduced ground space, simpler installation with only a central support needed, and is easier to mount high on a mast or from a tree limb. There might be a slight signal gain loss, but the antenna is slightly more omnidirectional and offers enhanced vertical polarization. The math is not too difficult. It's actually 460 divided by the frequency in megahertz for the entire length of the antenna, and the center part, which just has the coax section, is 325 divided by the frequency. Or you can just Google DIY double bazooka, and there are several calculators out there that will allow you to just type in the frequency that you want. One of them, at least, asks what the velocity factor is of the coaxial cable. And RT8X is 85%. And I tried that one first, and it also has metric measurements. And that would be this one. And, well, metric measurements are easier to deal with, millimeters, centimeters, a lot simpler. Divide by 10, whatever. But when I tuned them, this one I used without regarding the velocity factor. And when I hooked it up to the Nano VNA or Mini 1300 that I used, it was spot on with an SWR of 1.2.
Is that 220?
At 220, yeah. And this one here, I had to cut off 3/8 of an inch on each end to get it tuned up properly. So you save a little bit of coax, I guess. There's another option here for those that want to go online and look. That's a different WRAL, and it gives you the measurements in inches and feet. This is the master plan for a 1.25 meter double bazooka antenna. 2 times 8 and 11/16 inch is the is the length of the entire thing. Oh yeah, excuse me, I messed up. I have to correct that. This measurement should go out to the end. It's 17 and 3/8 inches for the entire length of the coax. Right? That's from there to there, entire length. And what you do is to carefully find the center. That's the most important measurement, to find the exact center of your cable. And then you carefully cut through the jacket and peel back the shielding. And one side of the shielding gets connected to your center conductor, and the other shielding gets connected to the shielding of your lead wire. And since the measurements are in decimal feet, you have to convert it to feet and inches in order to construct the antenna. So I've included this little conversion table right there. So now let's build one. Today we will be building a 1.25 meter, 220 megahertz antenna. We will use RG8 coax because it has an advantageous loss factor and is handy to work with. Coax. The double bazooka relies on a somewhat lossy coax to function properly. Never use coax that has a foil shield. First, we cut 12 3/4 inch piece of coax. Who's going to be the brave one? Shall we build 2 antennas?
Sure. Don't show it?
Yes. I don't have a ruler. And that's
What, no yardstick?
12 and
3/4. Anyone else volunteer?
Yeah, but let me see here.
Okay.
He's gonna do it. There you go.
yeah.
A fraction calculator.
Oh yeah, I got one of those too. Yeah. Next, measure 12 3/8 inch and mark from both ends to ensure that you have the center, and carefully remove the jacket from 1/4 inch on each side of the center. Carefully cut around the shielding, being careful not to injure the dielectric, and peel the shielding back to be dealt with later.
Should it have been 24 inches long total?
No. I don't think. Or does it? Oh. Yeah. Okay. Well, let's cut another piece then.
So it should be
Thanks.
24?
Yeah.
Okay. 24 and 3/4.
3/4, 24 and 3/4. Yeah. And the width of that space that you're cutting here should be just sort of proportional to the size of coax that you're cutting. It's not really that vital of a measurement.
Okay.
Okay. Next, carefully remove the jacket from 3 7/16 from each end.
All right.
What I did is when I made these,
Mm-hmm.
I put the coax flat on the table
Oh, yeah, yeah.
and then held the knife on it and just pulled the coax back.
Pull the coax back. And when you're doing that,
Uh-huh.
pull the coax through.
You know, hold it nice and flat, and the blade too.
Okay.
And then you peel the shielding back so it's back away from the uh, electrolyte there.
So this.
Just peel it out, just shuck it back like
Okay.
all the way.
Okay. All right.
And make sure it's all the way back to the
Oh, okay.
back to here. You know,
Uh-huh.
you might have to unfasten it or something. Yeah, you might have to pick it apart a little bit.
You got a spider right there. Don't move.
Thanks.
That's my job over here.
Yeah, thank you, thank you. Saved my life. It might be easier to cut off all but say a 1/4 inch of the stuff and then solder a piece of wire on there, but this way you get a better piece of conductor here on the end. You see
Oh, okay.
how I wrapped it around there
Yeah.
and soldered it?
No.
Well, the idea
Uh-huh.
was to get it looks with it pulled all the way back,
Yeah.
and then you wrap it around the center conductor once you cut the electrolyte off.
Oh, okay.
But let me see.
Yeah.
That probably will still work. Yeah, you just need enough to short it, to center it on there.
Okay.
Let's see, where's my thing here? Okay, and then you twist the shielding around the center conductor on both ends
Okay.
to make a short circuit. You might want to twist the whole wire all the way back too to give it a little more stability.
Question for you.
Yes.
So were these supposed to be cut off, or were you supposed to just fold them back and solder all of them together? Or is that?
Well, the way I did it is I folded it back and then soldered it all the way together. But you have to sit there for 20 minutes with that little needle and go, you know, unweave the shielding there, you know.
This would be just as effective, wouldn't it?
Yeah,
Okay.
certainly, yes.
Okay.
It's just I sometimes do things a stupid way. Okay, the next thing that you would do is involve soldering.
Okay.
If you can plug me in, and let's see. There we go.
All right.
It's heating up. You see the temperature?
Oh, okay.
Should reach like 590 or 600 or something like that.
$5.98.
That's close enough.
All right. Now what?
So, what I did it makes a lot neater of a connection and everything with your
Have we slid that
lead
forward?
wire. With
That
your
slid together?
Yeah,
I
right?
can't. Huh?
I think it's where we were handling.
Yeah,
That's it. We haven't done nothing.
that ain't right.
That's
So
where you soldered it.
yeah, thanks. You have to measure that again, like from the end.
Uh-huh. That should be about right. Measure it like this. So it should be half an inch. Yeah, it's
12 3/8 to the middle,
we're good.
and then minus a quarter inch. Right? Both of them the same?
No, but I don't.
No, I measured from
Oh, right.
from here to the end. That should be 12 and 3/8 minus a quarter of an inch, which is 2/8, 12 and an eighth.
Needs to be cut just a little bit, but
No, don't cut it. Move it. You know, we measured it on purpose.
yeah,
You know. No, from
right. Sorry.
yeah.
Right here.
Yeah, that's fine.
Okay.
All right.
Okay. So the next thing we'll do is I made it a lot neater. If you just take a piece of this hookup wire
Mm-hmm.
and wrap it around there,
Okay. Wrap it in the center.
I'll show you in a slide.
Okay.
There you go.
Okay.
And then
To
you,
each side.
yeah,
Okay.
out on the silver part.
And then the silver part.
And then pull it back so that the shielding is over it.
That?
Yeah, no,
No?
the shielding has to be shorted to the shielding,
Okay.
so that you're actually pulling the shielding back over that wire.
Wire just gives you really something else to solder.
Yeah,
Yeah.
yeah.
Okay.
See if you look at that. Yeah, and then you just solder it in place.
Okay. And
Hmm?
we've never done this before.
Oh, okay.
Just wrap it around.
Well, no.
Now I
Okay.
do know about solder.
Yeah. Okay. It's important to heat the object you're going to solder
Okay.
rather than the solder itself. But many times you have to get some melted solder on there. It helps to transfer the heat to the object you're soldering. Can you turn it?
Yep.
Yeah, like that. Yeah, that's perfect. And then I'll just put some tin this here, so that when you want to put your lead on there,
Okay.
you got it. Okay, next one. Same,
All right.
same.
Okay.
Next piece.
All right. I just
Well, you know, sometimes
the bugs
like
and
old
the heat
farts
and
like
not being able to sit down.
old farts like me that have been soldering
Frustrating.
for the last 75 years or something like that. We think everybody.
Is this a surface?
No, it's a portable screen they call it. It gets its power and its data signal through the C USB-C cable. What you looking?
I just need to cinch this up a little bit. It's a little loose.
Mm-hmm.
Oh yeah. That's right. Oh man. Oh yeah. So you're gonna solder it too. That's gonna hold it.
Yeah. Just want the braid to be in contact with the.
It just needs to be tight enough to hang in the right place until you get it soldered, you know.
Good tutorial. I've never built those.
Mm.
Okay.
Okay. Did you want to try doing the soldering?
Uh,
Yeah. Let me get that. Yeah. No. Okay.
Right.
Now hold it on the part first.
uh-huh.
No, the soldering iron. Hold the soldering iron.
Yeah.
Hold it on this the thing you want to heat first
Okay.
until the solder starts to melt.
Mm-hmm.
So hold it still now.
Yeah.
You want me to do it and show you?
Yeah. My
Okay.
hands are not
Okay.
steady.
Well, that's all right. Oops. Okay, now feed a little solder on there. Just a little bit.
Yeah.
Okay. We'll go around with it. Yes. Give me a little.
Okay.
Need some more solder on there.
Okay. Right here?
Yeah.
Yeah.
There we go. And once it gets the heat, it starts to flow.
Okay.
Go with the flow. And this we got to get rid of here. That's going to mess things up. Shoot. Not good. Yeah, we'll have to live with that.
Okay.
Okay, now the next thing you do is to solder this up nicely. What have I got on my cheek? A fly? Something. Okay. I guess I'll. This is just to keep the wire neat, you know?
Okay.
Keep it from shit, I guess. That's good. Next.
Yeah. Flies every time.
Thank you.
Interesting. Looked at doing one of these in a 40 meter, maybe.
Well, I've never built one.
No, me neither.
I'm gonna do a 40 meter next because there's one thing I didn't. So we're done. Well, next thing you do is your pigtail.
What you use? All points to do your
Oh, he's already got one made up.
Yeah, save a little time.
Okay.
So you just, well, just trim those off a little bit. It's good.
That's good.
All right.
Yep. Good enough anyway.
Yeah. Oh.
So that's it. That's the
Okay.
antenna. So do you want to tune it? Oh, I was going to show some. One more thing. If you're building a big antenna or you're using like fatter coax, like RG8 or something, there's this little box thing. Let me see. Looks like that. Tip that I got from a wise old ham. Its call sign is WA5T.
This would be mainly probably HF.
Instead of all that messing around with the center and cutting the insulation back and all that kind of stuff, you can make a little box like this. This box I got at Lowe's. It's in the electrical connection area there.
Who thought of that?
So you're talking.
Yeah.
Put ends on here and here.
I actually saw a finished antenna 40 meter from the UK that used one of those.
Really?
Yeah.
Never seen one until I came up.
Mm-hmm. So it makes it a lot easier. And the point is, really, about this is if you're going on a POTA or something and you're going to try out various bands, you can make a set of wires for more than one band, and all you do is, unhook the wire, hook the other one on, away you go. Mm-hmm. So, the end, das Ende, la fin, el fin, fini, whatever the heck.
Done. We're going to have the safety briefing.